Alright, welcome back friends. In our last lesson, we explored dynamic function calling with a simple example. We saw how different prompts could trigger one or even multiple functions at the same time. We also connected to an external API to fetch real-time data using those concepts. Now in this lesson, we are going to apply that knowledge in a real-world scenario, stock price and news. We will use the Yahoo query library to fetch live stock data from Yahoo Finance. You will build a solution where users can ask for a stock price and later even get the stock price and news together using parallel function calling. And by the end of this lesson, you will not only reinforce what you have learned, but walk away with a project you can proudly add to your portfolio. So let's dive in and start building. Let's head to Jupyter Notebook. Let's duplicate the script we created in our first tutorial for setting up the OpenAI environment. And if you haven't watched that video yet, or if your setup isn't ready, pause here, check out the first video in this series. And if you are finding these tutorials helpful, do like, comment and subscribe to stay updated and support the channel. It really helps me keep going. So let's dive in. So I have already duplicated my first OpenAI script and I have renamed it to fetch stock price and news. Let's begin where we left our first script. If you have already set up the environment, you must have already got OpenAI and Python environment. All you need to do over here before you begin is install Yahoo query library. I have already installed it, so I'll just comment it out and show you how we can install. And once you are done with the installation, make sure you import ticker from Yahoo query library. So ticker is a shortcode that represents a company in the stock market. Let's say Google would be represented by GWG, or Tesla would be represented as TSLA, and that's what we will be passing to our upcoming function. So let's see the example of user prompt. User may ask what is the stock price of TSLA today. So exactly, the user may not ask TSLA, the user may ask Tesla, but we are keeping it simple because we have to add one more API to search the name of ticker on the basis of company name. Let's just assume the user is directly passing this ticker name, and this is what we expect out of it clearly, right? No real-time data access. Let's begin by creating functions, and before that, first let's see how we can retrieve the data from the ticker. Let's say we have a ticker name Tesla, TSLA, which is the valid name, and all we have to do is we have to first create the object of this ticker class, where we will pass this ticker, and from this object we can retrieve the price data using the price property. Let's see what this price data contains. So effectively we are able to retrieve the values which are present on this interface for a particular ticker. We have passed Tesla over here. Let's say we want to retrieve this regular market price over here. All we have to do is we have to pass this key. So we have a ticker name, and within that dictionary we will ask for regular market price key, and we should be able to fetch the value. We can store it in a variable called price. And now let's define a function. Additionally, what we will be doing in our function, we will be handling in case the user is not passing the correct ticker value. We can add exceptions for that, and in case the ticker has not got this regular market price, we can also handle that case. Let's create a complete function called get stock price. So this is my function where we are doing all the things which we have discussed, and also we are doing the error handling in case there is no ticker data for a particular ticker. So let's just check this function. So in case, let's say we pass value Tesla, which is a company name and it's not a ticker name, it should go to this point, fail to retrieve Tesla along with whatever exception it has received. And if in case we pass the correct value, we should be able to fetch the stock price. Perfect. Now is the time to define a tool definition, but before that let's add couple of more prompts so that we can add one more function over here to fetch the stock news. Let's say instead of price, user wants to understand the news of Tesla today, so we can have one more prompt for that. And maybe the case user wants to understand both what is the stock price and news of Tesla today. This can be another prompt example. So we'll just comment these out, and let's design a function to fetch the news as well. To fetch the news, we can make use of any popular news RSS feed sources. Let's look at Google News feed. There can be other sources as well, like BBC or CNN, or we do not have any RSS feed for Yahoo Finance, so there can be news feed from Market Watch as well. So let's just stick with Google News feed in this case. As you can see, we are passing a ticker over here, and we are also passing the parameter stock. So in this Google News, we are looking for ticker and its stock news, and it will give us different kind of entries, like the title of the news and the link of the news, base source of the news, when it was published, what was the summary, and so on. To fetch this data, we need to make use of feed parser library. It is a Python module for parsing RSS and atom feed, and it will allow us to fetch, parse and extract structured data like headline, link, publication date, etc. In order to install feed parser library, you can install feed parser library in your environment with the help of this module. Mine is already installed. So to fetch the data from feed parser library, let's define a URL first, RSS URL, and we will simply pass this URL which we have used over here, the original URL with its parameters. Let's pass this to fstring so that we can have a variable ticker over here. So this is our RSS URL, and to get the data from this, we can create another object called feed, to which we can pass this parse method RSS URL. So let's pass a ticker over here. We get the entries over here for multiple news items which are part of this feed. We can access the news items with the help of this entries key, which will give us a list where each item is one news, which is again having a dictionary with the title detail, language, base, and many more attributes. In case we do not have any feed entry value returned, we can say no news found for. Otherwise, we can get the value in a list. And for each item, so you will see that this is such a long response. We will just fetch the, let's say, top 3 news out of this response. So we can say for entry in feed entries, we want to, let's say, want to fetch the top 3 news. We will give :3. For each news item, we will fetch the title with the help of get method. So entry dot get title, and similarly we can fetch the link as well. No sources provided, we can return the default value. We will append with this information that news items in the list news items, that particular news which has title, and we can also pass the link. So this will give us a list news item with 3 entries of news with. So let's run this first. So let's just comment this, since we will be converting into function. We have to save these in variables. So we have 3 elements in this news item, which is accompanied with the title and the source. To return the values, we can join all these elements. So this join will join all the elements of news items. Let's see what we get. We'll get something like this, where we have a one complete string. So this is how it works, and now what we can do is we can simply convert into function, and we can also accompany it with some try catch statement, try except statements, and otherwise we can finally return this as the latest news for this particular ticker. So let's do that. So this is what we get. So with this we are done with the another function which fetches stock news, and this also, while we describe this deviated us from the original topic where we are working towards a parallel function calling. We can call the individual functions and we can also call the two functions together. So from our understanding of the previous lesson, we already know that as a next step we have to define tool definition where we will be registering these two functions. So in last couple of lessons we have already learned to create tool definition, and so here it is now. For this case we have registered two function, get stock price and get stock news. Description is to document what the function does, and then it defines the parameters explicitly with schema defining what is the type of field required. In this case ticker is required, which is of string data type, and it is the required field, it must be supplied for that function. Additional properties is false. That implies that in case, let's say we give a prompt, tell me stock price of TSLA in India, let's say, so it will drop or ignore the part India where the region or country or anything is supplied. It will just take the part where the ticker is applied. So additional properties is equal to false. Now let's see how this tool definition will help us in defining how the LLM should behave or respond with different kind of user prompts. So first prompt was, what is the stock price of Tesla today? If we run it this as it is, right, we'll get that I'm sorry still, right? Why? Because we have not yet passed tool definition to it, and that can be done with the help of argument tools. And as you know, the default value over here is auto in this case. And now let's see what happens. So as you can see that now there is a tool calls, and in tool calls only one function is called right now, and that is get stock price as expected. Now LLM is returning the message that this function is to be called. And let's see the second user prompt. In this case, what is the stock news of TSLA in India today? It just picks the ticker name TSLA, India is ignored, and it calls the function get stock news. Calling the function, it's telling that this function is to be called. All right, and let's see the third part where the user is asking what is the stock price and news of Tesla today. How it works, we have a tool calls list where now there are two elements in it. One is the function get stock price, which takes the argument TSLA, and the other is this, which again has a function with the argument TSLA and get stock news. So here the LLM has given the response to tool calls of two function. So this is parallel function calling. Why? Here two functions are to be executed in parallel. Let's first save this message. Also let's save this in a variable, as we will be modifying it as part of conversation history and sending back to LLM so that we can maintain the conversation history. So let's save it in a variable called messages, and instead here pass this variable. And so we have this assistant message finally. As we know from our previous lesson that in case the message is completely irrelevant, we will receive this tool calls as none. So in case there is relevant function call to be done and tool calls is not none, in that case only we are passing the message back to LLM using chat completion AI. So for that, first we need to append the message. So for that we will first modify our message with the assistant message received, and we will send it back to, later we will send it back to the chat completion AI. We will send this message in the role assistant, as assistant or LLM has identified the tool calls. And we will also send another key where we are telling the LLM that these are the tool calls identified by you. We have to send it in a proper format. We can use model underscore dump, which will extract each and every value, which will make sure that we don't miss any value from the LLM response received earlier. It will go through each and every value of a function in the tool calls received in LLM response. And now let's see the modified message once this is done. Okay, so first we have to fetch this tool calls variable using the assistant message and the key dot tool underscore calls. Alright, so this is the modified message and this needs to be sent back to LLM. So this step is crucial because what we are doing, we with the help of modifying these messages, we are keeping the conversation memory constant, which will further help the LLM to track which tools were requested by the LLM itself. Now we have modified this message to maintain conversation history. We will be moving to our next step, which is actually executing the tool calls returned by the LLMs, and then further to that modifying the message back to maintain the conversation history, and finally we will see that how we will be feeding the result back into the LLM so that we can get the final response from LLM. So let's do this step first. For executing the functions identified by LLM, we will loop through the tool calls list which is there in the response of assistant, this one, right? We will loop through this list. We'll retrieve the function name and argument name with the help of tool calls dot function dot name method. To execute a function, we also need to fetch the args value which is to be passed to it, and that again with the arguments over here. And since there can be more than one function, we will make sure that we load it properly in a dictionary using json.loads method. Then we will actually start calling the function with the help of if statement over here. If function name is equal to get stock price, we have to execute it by passing the actual value of the ticker which is received from the user prompt, and we'll store the result get underscore stock price. So at this point we are just doing what LLM has asked us. We are just executing the function based on the values in the tool call. So this is dynamically done, and hence dynamic function calling is the name. If the function name is get stock news, we will execute it accordingly. Otherwise, in rest of the cases, let's say we'll do unknown function. Again, finally, we have to append the result back. With every function call, we will be appending the result with the tool ID which is executed. The point to be noted here is we are doing it in the role called tool because tool is returning us the result in this case. So we are adding role tool over here. Instead of function name, we are specifying the tool call ID of that particular tool, and tool ID is present in the response of LLM. And finally we are also appending the content. So we have role, we have tool call ID, and the actual content, that is the result of that function, in the form of dictionary every time a function is run. So here, like in this particular case, two functions are run, so this loop will run 2 times. I hope this runs well. Alright, so we have an error over here. It's double equal to, let's see the final value of messages. Complete history over is there. Initially we sent as a role what is the stock price and news of Tesla today, rule, and the second message which was sent back to assistant, that with the information what tools were identified, and third message is with the information of tools which were executed and the results returned by them. Now these are the results. This is the message which we are ready with, and now we have to send it back to chat completion API so that the LLM can return the result in a natural language which can be returned back to the application from which the prompt is coming. Let's do that. The final message. To get the final response, we can again pass the message to chat completion API, and this time we are passing this message which is just the complete modified message which is saving the conversation history from where the user started the prompt to what assistant identified as a tool call and the result of the tool call as the final message. And let's see what is the final response which we get over here. So as you can see that the chat completion API returns the response as expected with the result of tool call, as of today the stock price of Tesla and all that. This can be made readable on the application from which the prompt is sent. Let's make it readable now with the help of IPython display markdown, and to mark down we will pass the response content, and this is our final outcome. This clearly user is able to fetch the stock price and the top 3 news related to Tesla as per the user prompt. Now that we have explored how dynamic function calling works, it's time to dive into something really exciting, that is text embeddings with OpenAI. And in the next lesson, we will start with simple example to understand what embeddings are, how we can visualize them in the vector space, and how to create them using OpenAI tool. We will also explore how to measure similarity between embeddings, which will help us to see their real world usefulness. And if you are enjoying this series, don't forget to like the video, subscribe to the channel, and drop a comment. Do let me know what you think, and of course turn on the notifications so you don't miss the upcoming lessons. I'll see you in the next one.